So here's a question about solving the system of equations using two algebraic methods, substitution and elimination. For this video, we'll just be solving this equation by the elimination method. Let's start by labeling our system of equations. This will be equation number 1 and this will be number 2. Let's also rearrange our equation into the ax plus by equals c form, which is the standard form. So let's rewrite each one. It's 3x plus 12y equals 36, and the second would be 5x plus 4y equals negative 20. The good thing about rearranging them is that you could see that the x's are on the same column, the y's are on the same column, and the constants are also on the same column. It will be easier to eliminate a variable when they are arranged in column form. Now we cannot easily eliminate a variable here because the variables are of different coefficients. So our goal is to make the coefficients the same so that when we add or subtract the terms, at least one of the terms will get eliminated. So let's think about where would 3 and 5 meet. So think about their multiples. So 3 would get up to 15 and 5 would get up to 15. So 15 is a common multiple of 3 and 5. Same with 12 and 4. 4 times 3 is equal to 12. So this 4 can become 12. And then when we subtract, we can eliminate it. So I guess let's just eliminate y first by multiplying the second equation by 3. Okay, so let's label our work here. Let's first solve by elimination. Our first step would be, let's copy again our equations. Number 2. So like we said earlier, we will make this become 12, 4 become 12, so that when we subtract, we can eliminate the y variable. So 1, there's no need to eliminate or multiply equation 1 by any number, but we'll have to multiply equation number 2 by 3. Okay, so all of it will be multiplied by 3. Multiplied by 3, multiplied by 3, and we will rewrite here. Let's rewrite the first equation again. And the second equation, 3 times 5x is 15x. 3 times 4y is 12y. And 3 times negative 20 is negative 60. Now, as we can see, the coefficients of y are equal, so we can eliminate y by subtracting equation 2 from equation 1. So now we have 3x minus 15x is negative 12x. This is going to be 0. And 36 minus negative 60, be careful here because we are subtracting a negative number, which means this will become a plus 60. So 36 plus 60 should be 96. And then from here, we can divide both sides by negative 12. And you have your x value. 96 divided by negative 12, which is negative 8. So that's our x value right there. After getting the x value, we can substitute this x value into either the first or the second equation. I'm just going to use the first equation. Substitute x equals negative 8 in equation 1. I'm going to copy equation 1, giving a space for that x, 3x plus 12y equals 36. Our x is negative 8. Then we'll multiply 3 and negative 8. It's negative 24 plus 12y equals 36. Let's add 24 on each side of the equation. 12y equals 60. And then divide both sides by 12. Our y is now equal to 5. So our solution our x is negative 8 and y is 5. As an ordered pair, we will write it as negative 8, 5. Now you can check our work by substituting these x and y values in either of our equations 1 and 2. You could use the original, or you could use the one that is arranged in standard form. Okay, so let's try and check. Let's copy equation 1 again. This is 3 times the x plus 12 times the y value equals 36. Let's input the x and y values in there. X is negative 8 and y is 5. This is negative 24. This is 60 equals 36. 60 minus 24 is 36 equals 36. So it satisfies equation 1. Let's try with equation 2. Copy equation 2. Let's replace that x with the x value we got and do the same with the y value. So our x again is negative 8. Our y is 5. This is negative 40 plus 20 equals negative 20. Negative 40 plus 20 is negative 20. It's equal to negative 20. So we have just verified that our solution is really negative 8 for x and positive 5 for y, because it works for both of our equations.